team. Oh, excellent. Hi. And it's, yeah, nice to be with you all. We can jump into it where I'm going to post a video to this once we're done. So this will be accessible after the fact too. Can people hear me okay? I'm pretty sure we've got this set up, but just a thumbs up in the chat. Yes, thank you, Amanda. Cool. Well, with that, we can go ahead and get started. Yeah, so my name is Alex Stegg. I'm joining you today from Davis, California, just about 10 minutes outside of Sacramento. I am going to be demoing XSweet today, just to give you a little bit of background about where I come from. I was with the Cocoa Foundation through the end of 2018, and I worked with Adam Hyde and Wendell Piez, the programmer for XSweet. So with that, I'm going to share my screen here and pull up a slide deck, and then we will I'll run through XSweet to show you what it can do, putting some Word documents through it, and then we can take questions, go from there. So go ahead and share my screen here. So, yep, I'm talking about XSweet today. XSweet is an open source docx-to-HTML and beyond conversion pipeline. So, what does that mean? Well, the idea behind XSweet is that it will take your content from Word documents. Those are largely Word documents. You know, here specifically, Word is really probably the most common thing people author in, or at least a very common format. Anything from books to scientific articles, things like that. A lot of times it starts in Word, and we obviously want to meet people where they are. And this tool is designed to take content out of docx files and move it through a series of transformations into HTML, modern clean HTML. And from there, you can go wherever you want from the HTML. Oh, pardon me, I'm sorry for that. HTML was chosen as a good target format because you can publish straight to the web with it, obviously. And also because there is good support for it in terms of tooling. Tools that are available to go from HTML content into other formats if you desire. So under the hood, XSweet is really a series of XSL sheets, kind of grouped by functionality, what they do. Each one takes an input, applies a different mapping change to it, and then the output of one transformation step becomes the input for the next one. And XSweet is designed to be, modular, flexible, and extendable. And of course, it's open source. But the idea is that you can use what's there and use what you need and build something that you may need that is not there, and easily add it into a pipeline. So this slide just shows you, so under the hood of a Word document, a docx file is really a specific flavor of XML. There is a lot of cruft, a lot of additional markup that's really just noise. And so the goal is to take this XML from the Word document and move it into good, clean HTML, like you see on the right here. To talk a little bit about the architecture of XSweet, it's really divided into three main parts. The idea behind, well, each with a different function. Right, so there's kind of the core functionality of XSweet. That's really designed to extract the content and features from a Word document and represent it as faithfully as possible in HTML, preserving things we care about, formatting the content itself, footnotes, endnotes, tables, things like that, and really in an unopinionated way. We just want to represent that as simply and cleanly as possible in HTML. So that's kind of the core functionality. Beyond that, there's also some parts of XSweet that are really enhancements. Those are optional, opinionated enhancements. That are go beyond really just simply reproducing what you see in the Word document as HTML. And those are things like copy editing cleanups. For example, changing 2 spaces at the end of every sentence back down to 1, changing N dashes and M dashes into whatever they should be for, say, if you're building a book. Things like trying to guess at headers and footers, turning plain text URLs into hyperlinks, things like that. And then the last part of XSweet is really there's some steps built in to go from HTML into specifically Editoria. I'm sure that many of you are familiar with Editoria, online in-browser book building platform. And that is looking for a specific format for its wax editor. So there are some steps beyond the HTML to transform HTML into the markup that wax would expect. And that's just one example of where you can go from the HTML into really whatever target format you want. I'm just going to take a moment and check in here the chat to make sure there's no, yep, I'm not missing anything. Looks like we're good for now, so I'll keep going. Inception with the windows there. Yeah, so that's a little bit of the overview of the architecture. So what can it do? Right, as I said, it's kind of broken into 3 different portions: the extraction, the enhancement, and really the output. So the extraction that captures the content of the text. That will take your formatting from the Word document, both inline formatting and paragraph level formatting, things like bold, italics, underlining, such, and then represent that as HTML. It has support for tables, so it will really rebuild tables that it finds in Word documents into HTML tables. I'll show you an example of that. Lists, it can handle lists, nested lists. It will take math format, if you have inserted equations into your Word documents, that's something that it can handle. And it will also capture endnotes and footnotes. These are the Word implementation of endnotes and footnotes, and it will reproduce those with some links, so clickable links in the HTML that take you to endnotes and footnotes. Some of the enhancements that I already mentioned. It's got some heading inferring. What that means is it will, if you have a text, Word document without semantic tagging, and that really is what most author Word documents are. They don't use semantic tags to indicate what the different parts of the Word document are. Most of the time, people use things like visual cues to indicate their headings. Headings 1, 2, 3. Looks like changes to font size, changes to the centering, the alignment, bold, italics, underlining, things like that. So based on what XSweet sees in a Word document, it can make some guesses at what might be a heading. Not always going to get it right. That's the nature of the beast. But it's a good starting point, or can be, for a human to double check and improve upon. It can capture plain text lists. So if you've written out a list, 1, 2, 3, as opposed to using a the list functionality of Word. Can make some intelligent guesses about what might be a list and represent that in HTML as a list. Like I said, recognizing URLs when it sees them and hyperlinking them, copy editing cleanups. And in terms of output, for XSweet, kind of the core philosophy is to get to HTML representation first, from that Word document, and then from there transform it in subsequent steps. Like I said, for the wax editor in Editoria, so you can upload something straight into Editoria. We also have pulled in an ICML export option using existing XSLs, and that's something I can mention as we go. How can you run it? It's really up to you. So as an XSL tool, and given that the goal of XSweet is for it to be flexible, there are many different options for how to run it. So it can be run on different types of machines. We've had some great community contributions, to ensure that it can run on Linux, Mac, Windows. You can run it with Ruby scripts. I'm going to show you just how to run XSweet using some helper Ruby scripts that I created. They invoke some shell scripts. You can set it up as PHP scripts, and Docker virtual machines. Some of you who are familiar with Editoria may know that the backend is run on it's a JavaScript library called PubSuite. It has its own job runner that can execute jobs, and that's running XSweet to accomplish the Word document uploads into Editoria. You can also ask XSweet to create a new file for every step of the transformation pipeline it goes through, so that you can. That's really helpful as you're working with it, trying to figure out what each step does. You can inspect kind of the input and output of every step. Or if you're running it in a production setting, you might go for speed as opposed to outputting every step as its own individual file. So that would you could set it up so that it produces one output for one file input, at the very end of the pipeline, as opposed to all the intermediary steps. You can also set up some of the XSLs so that they invoke all of the XSLs in the pipeline from within one XSL. Those are just production enhancements for speed. But the point is, it is really designed to be flexible and to give people options as they're using it. So here is this is just it's going to link to the documentation, some of the repositories. I would encourage you guys to check out the the Mattermost chat channel for XSweet. If you're curious about it, if you have questions, you can find us there. We also have a guide to how to contribute. We think those are pretty reasonable. It's really encourages you to discuss what you're going to build, and then we can go from there. But it's designed to be something that anyone can get involved with. And just some of the people involved, I'd like to call out Wendell Piez, sort of the XSL guru who largely built this pipeline. Adam Hyde was really was behind the concept of this, and from going to from the Word document to HTML, kind of as a lingua franca to then be able to export to other formats. I've been involved with XSweet just specking out some of the functionality and working with Wendell in the quality control. And then we have gotten some great community involvement. Right now we're working with some folks at Amnet Systems are working to build track changes support, to be able to capture track changes and ultimately to pipe them into WYSIWYG editor. and many more. I'll post links to these with the video as well. But with that, I would go ahead and move on over to the, sorry folks, move on over to the demo portion of this. So what I would do for this is just show you a little bit of what it looks like under the hood, how it runs, talk through some of this stuff and then open it up for questions. So what I'm going to show you right now is just kind of a simple way to run XSweet locally on your own computer. So I have a couple of sample Word documents set up to convert. And so here's a Word document. This is my XSweet demo file. Right now, this is really just a very simple demonstration of, it's just going to give you a quick example of some of the things it can do, and I'll show you what the output of this looks like in HTML. We'll see a little bit more interesting examples as well. We're going to start with this. So as I had mentioned, under the hood, a Word document is really just, it's a zip archive that contains some XML. So you just make a copy of a Word document, change the file extension to a zip, and we can unzip it. Look under the hood. So now we're looking at the inner workings of a Word document. This is the main body of the document. And as you can see, there is a lot of markup for every little bit of content that you can actually see on that page. Maybe it's not fair because I do have math and some tables, which are a bit more complicated than your run-of-the-mill, just kind of mostly prose document, but really there's a lot of noise here to cut through. But so yeah, now I'm going to go ahead and I'm using right now, I've downloaded and I'm going to run through some Ruby scripts on my computer. Just to we're going to output each step of the process as its own file, and we can open those up and look, so you can kind of see what we're doing on our way to the HTML5 that we're going for. So this is just using some simple, it's some Ruby scripts and some shell scripting just to run the XSL sheets. Let me show you actually what that script looks like. We have here, really is it maybe 16 or 17 different XSL sheets. So an XSL sheet, right, for those of you who aren't familiar, it's really just a way to specify mappings from one XSL format to another. So to, how to handle specific tags. You have an input and an output. So each one of these steps here that we're linking to is its own step of the process. You can see here, based on these files are descriptively named. So the very first step is going to go from this XML under the hood of the Word document and pull out all of the information that we think we might want to use, that will be important in making a representation of the contents as HTML. So this first step here is actually going to run a couple different steps under the hood. We're also going to look at, as the next step, we're going to take the output of this first step and pass it in. It's got this own note, handle notes here. This will look for any endnotes and footnotes in the document, and recreate those from the Word XML to some HTML, endnotes with inline links. some elements or some steps here. They're going to scrub away, just simply drop a lot of the XML that you will find under the hood of the Word document that's just not relevant. And that's kind of, that contributes to the Word functionality, but that we aren't interested in. It will join some like elements, so if there's long runs of the same elements repeated, and adjacent, to combine those into fewer HTML elements. So you can see a lot of this is quite fragmented. And so a lot of that work is just gonna collapse that down into fewer tags. We'll go through some of the steps, but you'll see there are also there's its own step to handle math, some step to look for what we might tag as headings, H1, 2, 3, etc. So the point of this is just to see that there are different chunks of functionality that are each handled by a separate step. So let's go ahead and give this a run here. I'll set it off running. So I've really just set the script up so that we're looking at three Word documents. It knows where to look. I already pointed it at them. But what you're seeing here is it's as this pipeline is running, it's creating a file for every step of the process. After it runs the initial XSL, it creates this initial file and then uses that as the input to the next step. So here we're left with all of these different documents. Some of these kind of go beyond the initial HTML that we're going for. This one right here is the HTML that's been created from this Word document. So let me pull them up side by side so you can see those next to each other. So as you can see, right, I captured this list with the nesting, a lot of this formatting. You'll notice here there's a footnote at the end of this sentence, which links down to the end with this important information. And what that's created, or how that's represented in the HTML, is as an inline link, which will take you down to the end where it's holding this, this footnote here. Let's see, you can also see we've recreated this table here. XSweet is designed so that it can handle right now cell alignment, both horizontal and vertical, as well as horizontal and vertical cell merges in tables. And you can see as well that it's captured these math equations and represented them as part of this HTML document. Let me show you two from this side of it. I'll just open up the same file that we're looking at in the browser in a text editor so that you can see what this looks like under the hood. And we can compare that to how it initially looked under the hood with as a Word document. And as you can see, there's much less text on the right-hand side, the HTML side. Again, that's just a lot of the information in the Word document has been dropped away as unimportant, important only to the internal workings of Word. So what you're left with is a much cleaner representation of the document as HTML. That one is not a particularly realistic example here, and so we I have here a Word document that's a little bit closer to what some of you might see in the real world. Of course, depends on what you are using or interested in using XSweet for. This here is a scientific article, peer-reviewed article from PLOS ONE. Actually, that's where I got my start in the open publishing world. You can see here has some images, and it also has in here as well some endnotes, results, so kind of the normal things you'd expect out of a scientific paper. And let's see what this one looks like in the browser. Here you can, I see that this is, there's some bolding that's you'll see on the in the HTML document here that you don't see over in the Word document. And I suspect, let me just confirm, and I did cheat ahead of time. You'll see that this abstract here is an H2. So I just confirmed this would work, but on this, this is an example of the header inference. So this is this isn't semantically tagged in the HTML or in the Word document, but what you're seeing here is XSweet, as it was running, the header promotion step kind of guessed based on the formatting and the length of these, abstract introduction, materials and methods, that those might probably be headings, and then tag them as such. So again, that's never going to be 100% accurate, because it is just guessing at what it's seeing based on visual styling, which is very difficult for a computer to do with, if not impossible for a computer to do with perfect accuracy. You can see here that it's pulled the image out right now under the hood in the HTML. This is just an internal or a local reference, to where it is on my computer. You can imagine that if you were using XSweet to upload, say, into an online platform, into a WYSIWYG editor, you could handle these images however you want. You would just have to build it into your pipeline. And you can see here too that it's taken the endnotes from this paper and created sequential links to them. And again, it's just linking to the end of the HTML document. I'll open that up under the hood. Let's see what that looks like. Now we're looking at the same thing. This is the HTML representation, just what you were seeing in Mozilla there. Some of the, yeah, here's that link to the image you were seeing. Some of the presentation decisions are left to the browser, right? So it is worth noting that this might look a little bit different in Chrome than it would in Firefox, than it would in something else, but that's nothing new. Okay, so now let me show you one example of how you might use this all together. So, one, if you were using XSweet to ingest Word documents, and you wanted to syndicate them to the internet, this is something that you could post straight to the internet, and you'd have your HTML and you'd be done. What you can do with it as well, though, is it's built into Editoria. I'm sure this will look familiar to some of you. This isn't an Editoria demo. This is an XSweet demo, but Editoria is a book production platform built by Coco, and it uses under the hood uses XSweet to achieve uploading Word documents, from Word. Again, what the author may have written in. Again, that's the vast majority of what people are writing in terms of scientific papers, manuscripts, book chapters, things like that. So you'll see here, this is using PubSuite, and PubSuite's job runner to take an input docx, unzip it, run it through the chain, the XSweet pipeline, and then go from, it goes to good HTML first as an intermediary step, and then it takes the last few steps go from valid standard HTML and bring them to put them through some changes to change them so that they work with the wax editor here. This is a WYSIWYG editor that's representing it's an HTML-like structure under the hood here, but not exactly HTML, of course. This, and this is just an illustrative example of what you might want to use XSweet to do. Anyway, with that, I would open it up for questions and discussion, and I would thank everybody for joining. It's appreciate you all's time, and that's the last time you'll see that. And so, yeah, I'm just looking at the chat now. So one question, what typeset does XSweet render the math equations into? Ooh, it has been a second since I've looked at the math. It's not math check. I'm going to have to get back to you about that. I would, actually, you know what? This is a great opportunity for me to check the documentation. You've caught me out here with the math. Okay, it's going from Office's MathML into a word representation of math, or into HTML MathML. And this is an example of what I'd alluded to with MathML. Chrome does not represent MathML like this. I think Chrome would just turn this into what looked like really plain, kind of unadorned text. This is how Firefox renders it. Good question. And then I would point out too that say that you didn't want to handle math that way. Say that you were getting documents in a different format, and you knew that there was a different library people were using for math, for kind of what you were seeing. So you'd be able to, I'm going to go into the code here. This is under the hood. We're now looking in the kind of the library of XSL sheets that are chained together in this pipeline. So here's the code that's doing the extracting of the equations from Word, and passing them out represented in the MathML that you get in the HTML document. But the point of showing you this here is if you were getting math in a different format, you swap out this sheet with another XSL sheet that would capture that math. If you didn't already have one, that would be something we would encourage you to build. Then as soon as if you had an XSL sheet that could capture what you needed, you could just swap it in. Swap in your own math sheet in here and add it into the pipeline instead of this. So that is an important reason that it was built the way it is. Again, we broken up into bite-sized chunks that you can again use as you like, and swap out if there's something else that meets your need. That's definitely one thing that's I'm sure I'm preaching to the choir here, right? But within the publishing world especially, one size does not fit all, and then everybody has their own separate workflows, processes, and it's like that last little difference, between what everyone is doing that is really crucial to be able to allow people to configure so that it works for them. There's a question, can I watch your presentation online again? Absolutely. Yeah, I realize that we're talking to people around the world, so I'm live streaming this right now to YouTube, and I'll make sure there are links available. But this is recorded, yes, so should be available on the internet for posterity. I would add on to that too that I would encourage anyone to, again, find us on Mattermost and reach out to us there. And we're always happy to engage with people. Let's see. I think we're caught up on the chat with that. So yeah, I would open it up. Is there anyone who wants to jump in with questions? You know, feel free to just go ahead. And if not, that's okay too, of course. I'm hearing crickets, and that's perfect. I think that means that this has been an exhaustive recap of what XSweet can do. So yeah, if things do occur to you, yeah, feel free to find us on the Mattermost chat, and happy to answer questions, talk with you all. You're more than welcome to try it out yourself. I'm happy to help you guys get it running. If you have questions about the easiest way to run it, and if you do start running it, find bugs, feel free to open up tickets, issues, and GitLab. Again, we are always keen to work with folks who are interested in what XSweet can do and want to get involved on a deeper level. So, okay, yeah, well, thank you all. I appreciate it. I will leave it at that, and yep, go check out, see how the video came out, and make sure that that's something that's available for everyone who's interested in seeing it. So thanks very much. Really looking forward to yeah, checking out some of these presentations over the coming weeks. Okay. Take care, folks.